Now that I've completed the model construction, I'm going to move on to the rock mass domains. So in this case, we're keeping it very simple. We've only got one material, which is specified in here. So you select whether it's going to be a rock or a soil. If it's a rock, then these properties appear here, which are the properties that are required for the improved unified constitutive model, which is IUCM. Again, if you've got any doubt with what these are, then simply just pull up the help and you'll see some explanation there. So we've got the density, Young's modulus for the intact material, that is, geological strength index, and then I've entered an MI, a UCS. Now it's very important that this is for the strength of the intact rock blocks that are bounded by the discontinuities. Now those blocks themselves may have defects or heterogeneity in, so you may want to use some of the advice in the literature which shows you how to downgrade the intact UCS from laboratories to represent that heterogeneity. And then we have the disturbance factor. Now, as you can read in here, we don't really promote the use of the disturbance factor when you're using the IUCM. Now this is really because the largest part of the D factor is actually the damage that results due to the stress relaxation as you excavate a rock mass, and that is inherently built into IUCM as part of the strain softening, and these values here are for the residual strength as well as the critical strain reduction value. Now we wouldn't really suggest altering these values unless you're particularly familiar with them, so you can read the guidance to provide a bit more clarity if you wish on those. So moving forward to the anisotropy, IUCM can actually represent this explicitly using ubiquitous joints. So if you select this, you can assign a dip and dip direction and a minimum MI and an anisotropic factor. Now that factor is the relationship between your maximum UCS and your minimum UCS. So it'd be really important for representing that weakening effect of, say, foliation, bedding or schistosity. Okay, moving forwards, we're not going to have any anisotropy in this example, so we'll move on. Just to highlight here, I can actually enter some names into the domains here, so let's just try to say like this, and then you can add further domains in by entering the plus button, and obviously adding more names, and again entering your values. So I'll just remove that and remove that because we've only got one here, and I'll change that back to host. Okay, so moving forward to the faults, we've actually got two faults in this example. I've given them a thickness of 6 meters, and I've uploaded the file here, and the actual controls for the material strength is the same as the rock mass domains. As in an octree mesh, they are actually modelled as rock mass domains, not as interfaces. Now finally we have the in situ stress. In this case we're going to just have it as a simple stress field. So I've entered the K ratios there, and you can have a more detailed stress if you wish, but we're going to keep it quite simple. So that's all the parts complete now. I'm just going to click generate, and I now have a input file which is generated within the folder, and that's all ready to load into FLAC3D now. So let's just bring up FLAC3D, create a new project. That's going to be in that example file. Now we'll just open the input file. Now I've clicked on edit there, it's important. And you can see it's all there ready to run now. You don't need to worry about editing this at all, as long as you've put the correct values in the graphical user interface. Okay, so let's set that running. And just to show you what the model looks like, I'm just going to create a plot of the zones and stick on a cutting plane. Okay, and let's just zoom in here, and you can see the mesh starting to generate. I'll just leave it run for a minute so you can start to see it all come together. So now it's starting to group the zones. You can see the area of interest now defined, which has the higher density mesh. And in there, that's probably an intersect of a fault. And it's generated a save file for the mesh. And now it's moved on to the next stage, which is assigning the actual geometries. So now it's saved that. So of course you can restore from these points at any time if you wish. Now it's actually saving the model inputs. It's assigned all the strength values to the domains. And now it's refreshed that the main plot, ready for the run itself. Again, we can turn these on if we wish during the run. And you just need to be careful if you have the say this contour of displacement on, then it's going to slow down the run a little bit. So let's just turn it off for now. Turn this back on, and we'll just turn the cutting plane off and just show you the extent of the model there. There we go. Okay.